Chemistry, Unit 3, Electrolysis for Dummies. So in this session, we will introduce a step-by-step menu as to how to use electrochemical series to determine the products of electrolysis. Okay. So step 1, you gotta have your electrochemical series ready. You must have it, okay? And this time we're looking at it vertically. That is, we draw a invisible wall on these reversible arrows. And when we have different species to compare and contrast, we either only look at on the left and compare them, or we only look at the right to compare them. Okay, so as you know that water is a species that can exist both on the left and on the right, this becomes very important, the principle, okay? You gotta only either looking at the left or only look at the right. So on the left, we are always looking for that top left one. That is a stronger oxidant that's going to be prioritized to go through reduction. On the right, we're always looking for that bottom right one. That is, the lower you are on the right, you are more likely to be preferred to go through oxidation. Okay? Step 2, we're going to write down the species on both electrodes. Okay. So this might be a little bit hard for people because you would feel like this sodium chloride solution. So you have sodium cation, chloride anion, right? Because they're in the solution. And also you have water. How do I know which one is going to be present and which one? Well, if you can't determine that, just look at the power supply. The negative end is always going to attract something positive or something neutral. Yeah? So if you already have a negative charge, you're either attracting the positive charges or neutral charges. Because if you don't have any charges, you will be attracted by something that has a charge. Okay? So on the other end, that's the positive end of the power supply. It's definitely going to attract something that's negative or neutral, right? So for neutral species, it's going to be attracted by both electrodes because they have polarities, okay? And that is also the reason why water is always there, whether you look at the cathode or the anode. Okay. So since water is always there, our competition starts. So how do they compete? The cathode species on the left-hand side is found, and then anode species is found on the right-hand side. So cathode, what can be reduced? The two species are water and sodium cation. Can you find both species on the left-hand side on your data book? Yes, you can. Okay. On the anode, you're looking on the right. Can both chloride and water be found on the right-hand side of your electrochemical series? Yes, you can. Okay? So you notice that there are two equations regarding water, but one water is on the left, one water is on the right. This is where we must have an invisible wall in between so we don't confuse them. Okay. Once we found 4 reactions, our principle is the old principle. Okay, nothing has changed. You are looking for the higher left and the lower right, and you look at the left for the left, look at the right for the right. You don't compare the left with the right. Okay, so cathode, that's the left species. We're looking for which one is higher. So the higher one will have higher E values, which is larger E values in this case. So the negative number, which one is larger? Water is larger, okay, because it's negative 0.83. So on the left-hand side, water is higher, so water is chosen. Again, on the anode, we're looking for the lower right. So the smaller the E values, the more negative the E values, or the smaller positive number of the E values will be the lower right. Now, which one? Water is the lower right compared to chloride, okay? So again, water is chosen. So you notice that because out of both competitions, water is chosen, okay, in both cases. Therefore, your overall reaction would just be water either being reduced or being oxidized on both electrodes, okay? But when you are writing your overall reaction, the bottom right reaction is written as a backward reaction on your electrochemical series. But in the interest of you writing that overall reaction, you're going to flip that bottom right reaction into a forward reaction. So you have electrons on one side, on the left-hand side for the reduction half equation, and electrons on the right-hand side for the oxidation half reaction. Okay, so then you add them together, cancel out the electrons, you have your overall reaction, which aligns with the observation if you actually do this experiment. So oxygen is going to be formed on the oxidation side, that's the anode, which is the positive end. And your hydrogen gas is going to be forming on the negative end of the electrode. Okay. So there are several considerations that you can expect, because whenever we use electrochemical series, it has to be exactly under standard conditions. But in this case, with electrolysis, sometimes when the two half equations are too close to each other, in practice, it is possible for both half reaction to happen in the same direction. Okay, so experiment is the only way to test which or whether the reaction is going to happen.